This is a telescoping series. The main idea is very simple. We need to write out few terms and watch what cancels. A common mistake is trying to add the fractions directly. Please do not do that. First, look for the pattern and then do the cancellation. Let us go ahead and start by writing the partial sum. So the partial sum is Sn, right? So I'm putting n here because n can be anything, right? So this will be the summation from little n 1 to the capital N. So this is just some arbitrary number. And the nth term remains 2 divided by n plus 1, then minus 2 divided by n plus 2. At this stage, we can just go ahead and substitute, right? So what I would do here, I will start plugging in the values for what? The values for n. So when n is 1, right? When n is 1, we are going to have 2 divided by 1 plus 1 is 2. Then minus the same thing here, 2 divided by 1 plus 2 is 3. Okay? Then we add, right? So we continue adding when n is 3. So the first one here is when n is 1. So when n is 3, when n is 2, I have 2 divided by 3. Then minus, we do the same, right? 2 divided by 2 plus 2 is 4. So this is when n is 2. Then plus, let us go ahead and include the third one. So when n is 3, this is 2 divided by 4, right? Then minus 2 divided by 3 plus 2 is 5. Okay? Then plus. So you can observe that we continue adding, right? Then what about when n? So this is when n is 3. Okay, so what about when n is the capital N? We're going to have 2 divided by capital N plus 1 minus 2 divided by the same capital N plus 2. Okay? I just plug in where there is little n, I put capital N plus I just put capital 1, capital N. I just plug in where there is little n, I put, n is equal to the bigger N. Okay. Now let us observe. You observe that every second term cancels, right? This is negative 2 over 3. This is positive 2 over 3. So these ones, they give you 0. In the same way, you can have negative 2 over 4. This is 2 over 4. So meaning that the 2 over 5 is going to cancel out with some 2 over 5, right? So everything cancels with the next one. So meaning that before 2 over n plus 1, there will be some term that will cancel out with the other term. Okay, so we cancel the other term before 2 over n plus 1, which cancels with this other term. Okay, so meaning that you're only going to remain with the first term, which is just 1. 2 divided by 2 is 1. Then minus the last term, which is 2 divided by n plus 2. Okay, so meaning that Sn is given by this expression. Now, let us go ahead and see. We want to decide whether this thing converges or not, right? So we can only decide if we take n large enough. What it means taking n large enough, it means finding the limit as n goes to a bigger number, infinity. So this is Sn, capital N. This is just the same as, let us take the limit as n goes to infinity of what? Of 1 minus this expression, n over 2. Okay. Now let us go ahead and observe one thing. 1 remains unchanged, right? As n goes infinity, 1 is not affected. But look at this. This number 2 over a very big number, right? 2 over a very big number is 0, right? Because when you increase the denominator, this number reduces and approaches 0. Okay, so the limit here is just 1. So therefore, we conclude that the series converges to 1. This problem is a telescoping series, but it is slightly hidden. Why? The hint is in the denominator. Look at the denominator. You have n squared minus n, right? Which is just factoring out n, I have n minus 1. So you can see that you have 4 divided by n into n minus 1. So it tells you that you need to remember some partial fraction decomposition. So I can rewrite this expression as n from 2 to infinity, then 4 divided by n into n minus 1. Let us go ahead and use partial fraction decomposition. And this is just the same as a over, let's say, n minus 1, then plus b over n. We have a and b because these are just linear. We have a and b because these are linear factors. So we can multiply throughout by n into n minus 1, so that we have, on the left side, we have 4, which is equal to, we have a n, then plus b into n minus 1. If you want, you can use the butterfly method. So we have a multiplied by n, and then b multiplied by n minus 1. Okay, so we have that. Then you can go ahead and expand this. So this is 4 is equal to an plus bn minus b. So you can see that we have a constant term 4 outside, which is equal to, I would say, negative. We have one constant term outside. We have one constant term on the left, which is 4, and a constant term is negative b on the right-hand side. So which implies that b is just negative 1. Oh. Which implies that b is negative 4. In the same way, on the left side, on the left side, we don't have a variable n. So this is equal to the coefficient of an. The coefficient of n here is a, then plus b, right? So remember, b is negative 4. So therefore, our a is 4. Okay. So we can put everything together. So this becomes, remember, we are starting from 2 to infinity. And this is just, let me just write this. So our series becomes the summation n2 to infinity of 4 divided by n minus 1, then minus 4 over n. At this stage, we can write the partial sum. So the partial sum is Sn is given by summation n starting from 2. Don't forget, we are going to n. And what is inside remains. This is 4 divided by n minus 1 minus 4, everybody divided by n. Now let us go ahead and start expanding, right? Now let us go ahead and start expanding. Remember, n starts from 2. So when n is 2, we have 4 divided by 1, right? Because n is 2, 2 minus 1 is 1. Then minus 4 divided by 2, right? So this is because n is equal to 1. Then we are adding, right? Because this is a partial sum. So let us continue adding. So when n is 3, this is 4 divided by 2, then minus 4 divided by 3, When n is 4, this is 4 divided by 3 minus what? 4 divided by 4. Then we can continue adding. We can continue adding, and adding. So when little n is capital N, this is 4 divided by big N minus 1 minus 4 divided by big N. Now observe that we have 4 over 2, which cancels with 4 over 2. 4 over 3 cancels with 4 over 3. So 4 over 4 will cancel out with some 4 over 4. And the term here will cancel out with 4 over n minus 1. So this tells me to say Sn is given by what? 4 divided by 1 is 4, that's the remaining term. Then minus 4 divided by n. So this is the partial sum. Now let us go ahead and find this limit. So as n goes to infinity, of 4 minus 4 over capital N. This should be very simple, right? 4 is a constant minus, as n goes to infinity, this goes to 0, and this goes to 0. So therefore, the series converges and the sum is 4. Okay? One take home is that the key idea here is first use partial fractions to rewrite the term. Okay? Then write out the first few terms and let the middle terms cancel. Don't force them if you're not canceling, right? In this case, all of them, they were canceling. So that is the power of telescoping series.